So if, for example, the problem we're working on is 1,576 times 23. The way Micaiah would do this is she'd start here, 1,000 times 20. Then she does 1,000 times 3. Then she goes 500 times 20 and 500 times 3. And then she does 70 times 20 and 70 times 3. And then 6 times 20 and 6 times 3. And as long as she keeps track of these and does them in order, it's never a problem. Every now and then she gets mixed up and misses one, or she puts an extra 0 in, but in this case, they're in order. This is 1,000 times 20, which is kind of difficult to think conceptually. So really we just do 1 times 2 is 2. And then we know this has been multiplied times 10 once, times 10 twice, times 10 3 times, times 10 4 times. So we have to multiply this times 10 4 times. And each time we multiply times 10, we increase the place value by 1. So there's increase by 1, increase by 2, increase by 3, increase by 4. And you'll notice that what you end up with is 1 2 3 4 zeros, 1 2 3 4 zeros over and above our answer. We're going to repeat this all the way down. 1 times 3 is 3 with 1 2 3 zeros. So I'm going to try to keep these all in line. This is something Micaiah doesn't do. It would help her, but she seems to compensate fairly well. Her problems are rarely the addition. My problem is addition, if I don't keep them lined up, so I have to. 5 times 2 is 10 with 1 2 3 zeros. So it actually ends up being a 1 with 4 zeros because the 10 already has a 0. So I'm going to do 1 2 3 4 and the 1. So 10 right here and the 3 zeros. Okay, 5 times 3 is 15 with 2 zeros. 7 times 2 is 14 with 2 zeros. 7 times 3 is 21 with 1 0. 6 times 2 is 12 with 1 0. And 6 times 3 is 18. Then she has to add all these together. This is why I have to keep them in line. 8, 4, 5, 10. I feel like I've already made a mistake. 5, 9, 10, 11, 12. No, I just counted wrong. 9, 12. Yep. I have to remember to carry the 1. 1, 2, 3, 4, 5, and 6. Make sure I'm doing this right. 4, 5, 6. Good. And then 2 and 1 is 3. And so her answer to this problem is 36,248. Okay, I would like Micaiah to try one of 2 different methods. First method, the box method. She would draw a box, and she would write out an expanded form, this one, on this side, because it's a smaller number on the shorter side. So expanded form is just 20 plus 3. And she knows this already. And then she would write an expanded form across the top. 1,000 plus 500 plus 70 plus 6. Okay? Just draw her lines down to break the box up. Okay. Now what I'm going to do here is I'm also going to break this box out to show you something, to show her something else, because I think I see where some people get confused. So this box is that box. This box is that box. And so on. All right. So this was 1,000. Okay. This was 20. This was 500. This was 70. And this was 6. This was 3. And I did it this way down here because I think what sometimes happens is kids fail to realize that this line is 3, this line is 3, this line is 3, this line is 3, this line is 3. This line is 20, 20, 20, 20, and 20. And that's true even if we do this out to scale with all the little boxes inside. This line across here is 1,000, which makes this line 1,000, which makes this line 1,000. This line is 500, 500, and 500, 70, 70, and 70, 6, 6, and 6. Okay. So step 1. Once we've done this, this is 20 times 1,000. Notice it's the same thing as McKay's been doing up here. We already know the answer from up here. So that's 2 times 1 and then 4 zeros. 1, 2, 3, 4. Good. I'm going to copy it down here so that we have it. She did this one up here, 1,000 times 3, which is the same thing as here and here. So that's 3,000. Just to make sure you realize I'm doing this problem twice. I'm doing it up here, broken out so you can see why this is the same. All right, the next one, 20 times 500. 20 times 500. It's the same thing she did right here. Ten and 3 zeros. 1, 2, and 3. 5 times 2. 2 times 5 is 10, plus the 3 zeros. The next thing she did is the next thing we're going to do. 500 times 3, or 3 times 500. 3 times 500. That was 15 and 2 zeros. Okay. And this is where it gets harder for them to see. This line is 3 right here. This line is 500, so it's just 3 times 500. Okay, so now this is 70 times 20. 2 times 7 is 14. There's 2 zeros. Same thing she did here. This is 70 times 3. That's 21 and 1 0. That one right there. Same thing she did right here. Getting to the final step, 6 times 20 is 12 and 1 0. Right here. And 18 down here, 6 times 3. Now, same thing happening here. She's still adding all those numbers up, but now they're in some semblance of an order, and she go down or across. But 2,000 or 20,000 plus 10,000 is 30,000. Plus 1,400 is 31,400. Plus 120 is 31,520. And Micaiah can do that kind of thing in her head. She's really, really good at this stuff. All right, 3,000 plus 1,500 is 4,500. Plus 210 is 4,710. Plus 18 is 4,728. And then she's going to add those up. And it would be the same thing across here. 31,520. And this one is 4,728. And in both cases, we're just going to add them up. 8, 4, 12, carry the 1. 4 plus 1 plus 1 is 6. And 3. 36,248, 36,248. This one's the same thing. So that's the box method or the area method. Only slightly more efficient than what she's got here. And the only reason it's slightly more efficient is she's less likely to lose track of putting all these numbers out and keeping these in order when she's adding them. All right, just slightly increase or decreasing her chance of making mistakes. The next higher level combines steps. And this is where she says she doesn't understand. So what we would do is we would write it out as the largest number on top. We would stack them. It's a 5-step process. Step 1, stack them. 1,576 times 23. Step 2, we're going to multiply the 1's place value on the bottom times the 1's place value on the top, and we're going to work our way across. 1's place value on the bottom times the 1's place value on the top, then the 10's place value, then the 100's place value, then the 1,000's place value. And I'll show you how this relates back to what Micaiah is doing here. So 3 times 6 is 18. I have to carry the 1. Okay? That's this one down here, by the way. 3 times 7, that's 21, but I add that 1, so that's 22. 3 times 7 is right there. And really that was 3 times 70, but we don't have to worry about that because it was 3 times 70. It was already in that place value. Okay. That was 22, so I have to put a 2 right there. 3 times 5 is 15, plus that 2 is 17. Carry the 1. So that's 3 times 5. That's this one right here. So now what we've taken care of is those 3 steps, and the last step will be that one right there. 3 times 1 is 3, plus that 1 is 4. Okay. If you notice, this number right here is this number right here. Oops, missed my camera just a bit. This number right here. Okay. This number here is the same as this number here. It's all these numbers across. Okay. Now, we are going to multiply 20 times 6. That's this one right here. But we could do 2 times 6 is 12. But if I wrote a 12 right here, I'd be wrong. I know the answer is supposed to be 120. I could write it as 120, or I could say that my step 3 is just to go ahead and put a 0 right there. And that's just a good rule. If I put a 0 there, I don't worry about the fact that that's a 20. Now it's just 2 times 6. 2 times 6 is 12. Carry the 1. 2 times 7 is 14, plus that 1 makes 15. Carry the 1. 2 times 5 is 10, plus the 1 is 11. Carry the 1. 2 times 1 is 2, plus the 1 is 3. Notice that number there is the same as this number here, because really what we've done is all these across here, we've just gone 2 times each of these across, just like she has already been doing. That's 20 times 6, 20 times 70, 20 times 500, and 20 times 1,000. And then all we have to do is add these two numbers together. 8 plus 0 is 8, 2 plus 2 is 4, 7 plus 5 is 12, carry the 1, 4 plus 1 is 5, plus 1 is 6, 3 plus nothing is 3. My answer is 36,248. And I can do that answer both faster and with fewer errors than I can do this answer, more prone to errors, or this answer, less prone to errors, but slower. Now, where it really starts to play out is when we start doing questions like 1,576 times 823. Because we have just multiplied that series of digits there by 3.